Hello, and welcome to our Wednesday webinar from the International Center for Sustainable Carbon. My name is Benedicta, and I'm part of the communications team here. Our monthly webinars are based on our reports, which are available from our website, www.sustainable-carbon.org. Residents of member countries and employees of sponsoring organizations can download our reports at no charge after a one-off registration at the website. Please type in any questions you have in the questions box as we go along, and we'll answer them at the end of this webinar. The subject for today's webinar is non-energy products from coal, presented by Dr. Ian Reid. Over to you, Ian.
Thank you, Benedicta, and welcome everybody to today's webinar. I'm going to talk about the link between products we can make from coal and coal derivatives, and the energy transition, and also the link to the International Panel on Climate Change as well. Some of these links are quite surprising, and I hope you enjoy the presentation. It also draws on a workshop we held in Italy 2 weeks ago, which drew an international a group of people together to discuss the massive changes that are taking place around the world as we engage in this energy transition. Now, my name is Ian Reid. I'm a principal associate at the ICSC. And in recent years, I've been working on a series of studies on alternative products from coal, and that's going to be at the core of this presentation. So there's a number of reports out there if you want to follow up on these things. Now, if we look at the current situation for coal, we're at peak coal. The emergency in energy, of course, is driven more coal towards power use, but in a fairly near future, there's going to be a fall in the use of coal, and that's going to provide an opportunity to use coal in a completely different way. Now, coal isn't just used for power for electricity. It's also used as a reductant in steel and for processing calcium carbonate into calcium oxide for cement. It's used for making chemicals and plastics, and it's also a growing presence in ammonia production. So the question I have for today is, what then for coal? Can materials that we can obtain from coal actually reduce the burning of coal, and so support our energy transition and our actions on the climate? Before I get going on that, I just want to describe what a hydrogen valley. Now, industries are looking at the best way to make hydrogen, which is going to intended to replace natural gas, so that we can decarbonize our industry. And this, how you make hydrogen depends on your location. If you have lots of cheap natural gas, you might reform and carbon capture the CO2 and make hydrogen that way. Or you might use electricity from nuclear stations if you have them. But in Europe, the intent is to make hydrogen from electrolysis using renewable electricity. And this picture on the right shows you some wind farms and around the Baltic Sea, some solid oxide electrolyzers, a hydrogen pipeline, and in actual fact, we will need about 400 wind turbines if they were 10 megawatt size, perhaps slightly fewer if they're at the latest maximum size. And we would need around 20 gigawatts to make 250,000 tons of hydrogen. And these wind farms would be created all around the Baltic Sea, and the hydrogen would then be piped into countries in Northern Europe, such as Germany. And that hydrogen would then be used for industry. Now, what has that to do with coal? Well, Construction of wind turbines, the long blades have to be made from carbon fiber. They're 80, 90 meters long and need that strength and lightness. The motor for the turbine requires rare earth elements. And we also need concrete and other materials for constructing this hydrogen valley. So if we look at rare earth elements first, now each wind turbine needs around a ton of REE. So that's predominantly neodymium, which is a highly magnetic element, but also other rare earth elements. And in fact, we need these rare earth elements in almost all our important devices. Mobile phones I've listed there, a third of all rare earth elements are used for mobile phones. But we're going to have electric cars, and they need 1 or 2 kilograms each. But we make 80 million cars a year. We need them for energy storage, lighting, all sorts of things. And the prediction from the EU is that the demand for REE in Europe will be 20 times what it is today within 1 or 2 decades. Now, there's 2 issues with that. One is the mining and refining of rare earth elements to achieve this massive demand, and also the fact that China has dominated the supply, not just through control of resources in China and elsewhere, but also by dominating the refining of the elements. Now, where does coal come in then? And it's because of this. Most coal doesn't have much rare earth element content, perhaps only 30, 40 ppm, but some deposits do, and it can be as high as 1,000 ppm. And if you look at the ash from coal, that can be up to 8 times higher than that, around 0.5%. And you compare that with rare earth element ores that are typically 4 to 8%, and there is a concentration challenge, but here is an alternative resource. Now, the latest pilot plant results have achieved 98% purity on obtaining rare earth elements from coal wastes and acid mine drainage and things like that. So the research is proven, and US DOE is now funding 4 pilot plants to show commercial recovery. In China, the processing of the ores into these elements has been environmentally disastrous, creating toxic lakes and contaminated land, and partly because of illegal operations. And so an aim from this work is to improve the environmental recovery of rare earth elements. On the one hand, we have renewable electricity from wind and the sun, but in order to process that, we need these elements, and we need an awful lot of them. At the bottom of this slide, I talk about flash fuel heating. This is a program from Rice University in the States. It's like an incandescent light bulb. You convert, say, fly ash into a plasma, and then you can recover the rare earth elements using only mild acids. That would be a massive environmental change in the processing of rare earth elements, avoiding the strong acids that are needed. Then I'm going to talk about concrete. I mean, I don't know if you remember, but I mentioned that we need quite a lot of concrete for this infrastructure we're building on the hydrogen economy. In fact, I think the number I saw was 300 tons per megawatt. We're building 20 megawatts in one hydrogen valley. Now, cement is making cement is one of our largest industrial CO2 emitters. So how can coal products make a difference? And the answer is, well, either we can use a lot of this hydrogen we're making in the hydrogen valley instead of coal to provide the heat to make our Portland cement, or we can substitute the Portland cement by fly ash. And the thing about fly ash is that originally it was made in Germany to make sulfur-resistant concrete, but now in China they're seeing advantaged properties from using fly ash instead of cement. And I've got an example here of the bridge tunnel complex linking Hong Kong to the mainland. When you use ash, you slow down the reaction and have a lower exotherm when you're curing concrete. And in that way, the cracking is reduced. Now, at the same time as we're withdrawing from coal power generation that makes the fly ash in Europe and America, we will need more for cement substitute, because it is by far the cheapest way to reduce the environmental impact. And sticking with the construction theme, there is alarm over how much construction and how much resources that will consume in the future. The price of cement has been rising much faster than the price of fly ash, by the way. We're concerned about whether these resources will be sustainable for the future. We've actually had more construction in China in 2 years than in the USA in the 20th century, which I think is quite a startling observation. This picture is of a completely new city in South Korea, a university city. Our population is still rising. We hit 8 billion people in this month, and that is set to continue rising over the next decade because people are living longer, and they will need buildings. They will need offices and places of work and so on. So we've talked about fly ash making an impact on replacing cement, and we could use heritage fly ash. We have to reprocess it, but that is there's lots of that available to use in the industry. But we can also use carbon fiber made from coal tar. The issue is that pine fiber is a very fantastic material, but it's too expensive for building. So we need a low-cost source of pitch-based fiber that can be used to strengthen concrete, so we need less of it. Reduce the weight that has to be transported, reduce handling. Another development is to use concrete as a CO2 sink. But the problem is that when we want to use reinforced concrete, that's not really compatible with the steel reinforcing rods. We could use carbon fiber rebar instead. So there's an exciting development here on using coal products. And if we move to the automotive sector, and here I have a picture of the Neo SUV, that has a removable battery pack, which is quite popular becoming very popular in some countries, such as Norway. It's entirely encased in carbon fiber, and that reduces the weight of the battery pack for handling, but it has other benefits as well in dispersing thermal hotspots and so on. The case for carbon fiber in aerospace has long been made. You can fly from London to Sydney for one reason, and that is because the plane is virtually the plane structures and is almost entirely made from carbon fiber. And when you look at the figures on fuel savings, they are massive from adopting material. But for vehicles, that is less the case. You don't have to raise a car into the air. But there are a number of advantages. We talked about how many cars will be built. I mean, currently, less than 10% of them are electric, but that's changing very rapidly. And they all need rare earth elements. If we could use less, have smaller motors, smaller battery packs to save on lithium, and still get the same range, and then actually get other benefits such as the safety of the vehicle or better handling, because the upper parts of the vehicle are lower mass, which lowers the center of gravity in the car, improving the handling. There's a lot of technical benefits to be had by adopting carbon fiber. Now, pan fiber there are competitions for the feedstocks for pan fiber and pitch carbon fiber, and that's partly why it's more expensive. And the production of tar is linked to steel, and that's really dominated by China. And so we need to find cheaper sources of tar to make this carbon fiber for vehicles, to get a revolution really in the materials of choice. The final material from carbon I want to talk about is graphene. Now, we're very early stages with coal to graphene. It's mostly made from natural gas depositing carbon onto a copper substrate to make graphene at the moment. But can you make it from coal? Well, actually, yes, you can. And why is that? Well, most coal actually contains graphene. So if you remove the more reactive material, you're left with graphene fragments. And that's true for electrochemical and molten salt techniques that I mentioned in this slide. Flash-fuel heating's a little bit different. I mentioned that for turning fly ash into a plasma, so that you could get at the rare earth elements in the ash. But you can do the same with coal, and you can convert that to a plasma. And actually, when the coal recombines, it recombines into graphene. Now, is the quality good enough? Well, as an example, there's a new computer memory device, a memristor. Now, memristors were only theoretical a few years ago, but now they offer a fast access permanent memory that competes with traditional computer technology. So as fast as a RAM memory, and you put RAM in your computer for speed, but you lose the data when you power down. That's got to be saved somewhere else, not with a memristor. So there's an example being made, but for an item like that, it doesn't matter what you make it from, whether it's gas or coal. So we're looking for applications where bulk graphene can be made from coal and then used in a major industrial application. And the one that's got people most excited is using graphene to strengthen. Oh, what's happened there? Using graphene to strengthen concrete. Graphene actually migrates to micro cracks in the structure and bridges them, giving a massive increase in strength. So you need less concrete. That must be attractive. Now, I'm going to leave the sort of industrial applications for coal products. We've talked about rare earth elements, we've talked about carbon fiber and graphene. I'm going to talk about coal in the agriculture industry now. And actually, there are a growing number of difficulties. We're facing desertification. We've seen in the news about the terrible famines gripping Africa at the moment. Deforestation. We're clearing forests because our lands are deteriorating, and so in order to maintain food production, we're invading the wilder areas. There's a general fertility decline in the health of soils, and that's exhibited by the carbon content. You need just a little carbon in the soil to support life in the soil. As little as 3% is enough. The rest is clays and water and sand and things like that. But many soils are not even making 2% carbon, and in those circumstances, the the soil cannot take up the nutrients that we provide. Now, the UN has got some major initiatives in this. They talk about the year of the soils, and actually there's a day of the soil now. And the latest focus has been on sodic soils. Now, this is soils that increase in salt content due to irrigation. And unfortunately, we're losing an area about the size of Cyprus each year due to this. Those soils are no longer able to support crops. Now, we talked about how many extra people we will have in the planet because of medical advances, and we're rising to by about 1 million a week. And these people will all need food, but we do need to protect our biodiversity, because that is the future of our planet. I'm now going to talk about nitrogen fertilizer, but actually it's not the only issue, because phosphate is also an issue. But I focused on nitrogen as a key example. Now, when we apply ammonia products, and that ammonia is normally made from gas, but obviously this year, with a huge price of gas, the plants have been closing, and it's the ammonia from coal is increasing rapidly in many countries. It's a prime use of coal gasification at the moment, making hydrogen for ammonia. But we're producing about 180 million tons a year. Most of that is used for agriculture, for fertilizer, but unfortunately, the planet can only handle about 60 million tons. So all the rest ends up in our rivers. And I forgot to show you on the diagram before. Let me just go back here to look at a picture of the planet, because I meant to show you this. At the mouth of every river and in every lake, you can see algae growth. Now, what this is doing is it's attacking the aquatic life systems. And in the Great Lakes in North America, they would be green like this once a year a decade ago, but now 3 or 4 times a year. And it just gives an idea of how the excess addition of nitrogen products and phosphate products is affecting our water life. Yeah, now, as well as this algae bloom picture caused by nitrates in China, so it shows the thick algae can be made. That removes oxygen from the water at night, and that's what kills off other life. But also, ammonia fertilizers degrade if they're not taken up by plants. So say urea is added to the soil, by the time the plants can take that up, it's been either washed out into our rivers or actually goes into our air, and that causes problems for breathing. So where does coal come into this? Well, the answer is this molecule I've got here, which is a HUMUS molecule. It's a large carbon-connected molecule with many functional groups. So all those O and OHs you see on there. Now, what do? Well, they latch on to these ammonia fertilizer compounds and phosphate ions, so nitrates and phosphates, and also water. So this molecule can retain water, which in arid conditions is very valuable. Yeah, I've mentioned about this 3% carbon we need. Well, we can add humates from coal. And why are they present in coal? Well, coal's made from plants, and that as they degrade, these humate molecules are actually left in the coal, and especially with immature coals, we can recover them. And there's already an industry that recovers humates from lignite using alkali solvents. Dissolve out the humates and then recover them. There's other methods appearing though. There's ammonolysis is an air and nitrogen treatment that adds more of these O groups you can see in the picture here. And I think it's worth mentioning the microbial techniques as well that can actually take on perhaps a wider range of coal and makes a natural gas, biogas, and also a soil product like this that can be used. And these act to lock in the nutrients until the plants are ready for them as the plants grow. And so the implication is that you need apply less fertilizer in the first place. And so if you remember that the planet can cope with a certain amount of fertilizer, but people are adding more because they have to do that to maintain crop yields, because less and less is being taken up by the plants. This could be transformational. And actually, it's not the only way of doing it. At our meeting, we heard about making zeolites from fly ash and using that to hold on to the nutrients. So there's various routes under development. The other side of it is, what else would we use to raise the carbon level in our soil so that we can grow our food? And I mean, people would turn towards peat, but actually we're banning that because we need to preserve our peat bogs, and because they're very important carbon sinks, as well as places of biodiversity. So if we move on from coal and agriculture then, and have a thought about gasification. Now, coal gasification is increasing rapidly. Around the middle of the last decade, we thought that this industry didn't really make sense. The low oil prices really meant that the industry was uncompetitive. And the only driver for it was countries wishing to use their own resources for chemicals. And that was particularly true in China, of course. And its main technology is to gasify coal to syngas, adjust the hydrogen CO ratio, and make methanol. And methanol can then be used to make plastics and fuels. And in fact, the world's largest new chemicals project in Zhanzi is using that technology to make ethylene glycol as an intermediate. While we're converting coal by gasification, there's also a traditional chemicals industry. And I don't know if you recall, but I mentioned that the route to coal tar for carbon fiber, pitch carbon fiber, it is linked to the steel industry and the processing of coal to coke. But China, that's dominated by China, and China is dominant in the traditional coal chemicals, and we still need those. For instance, naphthalene derivatives are used to give you smooth concrete, and there's all sorts of things. But they're also making carbon fiber there from their pitch carbon fiber. The chemical sector sits outside of the moratorium on coal power plants. When you make plastics from coal, about half the carbon is retained in the product. So there is a much larger CO2 emission than from petroleum, but not like burning coal. And of course, it sits outside the Paris Agreement on carbon targets, but is becoming quite meaningful in terms of emission. Now the picture with plastic waste. The thing is, no matter how you make the plastic, whether it's going to be from Europe's Hydrogen Valley processes or from coal, there's a waste, and it's a major issue for plastic waste in the ocean, and actually plastic waste in all of us. So major changes are about to happen in this industry, and it may mean that plastics have to be reformulated, recycled in country, and not imported, and certainly not exporting the waste. and this picture has to come to an end. But that has major implications for China's gasification industry. So I've mentioned the carbon intensity challenges and the CO2 emissions, but these plants, gasification plants, are actually capture already. CO2 is emitted as a fairly concentrated stream. So then you have to decide what to do with it, do with this CO2. And actually, there's major research programs around the world looking at using CO2 as a reactant to make fuels, actually using waste plastics to make fuels as well. So our research institutes associated with us, such as Sotocarbo in Italy and NEDO in Japan, are investigating this, because not every country has a place to store carbon dioxide. So what do we do with it? Well, in order to process CO2, we need a lot of hydrogen. And in China, it's just constructed a huge a huge coal to hydrogen facility that will need 3 million tons of coal and make 10 million tons of CO2. The CO2 recovery is absolutely desperately needed here. But this hydrogen plant on its own is greater than the Baltic Sea Hydrogen Valley in capacity that we looked at the very beginning, where we need hundreds of wind turbines to supply the electricity for the hydrogen. So that is a competitor. And hydrogen, of course, and China, of course, is leading in renewable energy, and it's also making hydrogen by electrolysis, and just the beginning of that. And what about economics for coal gasification? Well, oil is currently around $90 a barrel. We thought that the profitability was around the $50 per barrel mark, but actually the first rapid expansion of the industry took place when oil was only $40. So I'm coming to the end of my presentation. I've got a few more slides, but here I just wanted to take you back to what we can do with coal that can actually help our energy transition and reduce our climate impact. So it's very counterintuitive on how people regard coal today. We talked about carbon fiber and making lighter vehicles that need less resources. I mean, we need to move away from just converting SUVs to battery cars, let's face it. We talked about rare earth elements. It's not just that China has a monopoly, and in fact, a number of car companies have just announced that they're moving production to China so that they can get the pitch carbon fiber from coal, and they can get access to their rare earth element ores. We need it's a very unbalanced future for the world economy if that's the only source of what is more than a critical element, I would say. We've talked about graphene. Graphene is the most patented material. It's a very exciting material. All the material scientists are talking about a revolution in material science due to graphene, and the fact that we can make it from coal, and that coal will become cheaper in the future, is perhaps game changing. When we make coal tar pitch, the trouble is it's linked to the steel industry, and that's undergoing change. It's moving. How do we use renewable electricity instead for making steel, or use hydrogen as reductant for making steel? Is a question people are asking. Moving away from the coking coal industries. Now that is maybe a couple of decades away, but you can also make the coal tar pitch for these new materials we've talked about by making activated carbon. And activated carbon is a very valuable product in itself, and is used for purifying our water, and also could be used for carbon capture. We talked about fly ash on the left of this picture, and how that can be used to markedly reduce the environmental impact of cement and concrete. That is a major use of coal at the moment. We can actually reduce how much coal we need to use it for construction by adopting this. I show electrodes. Every battery, and a car battery is 5,000 cells, requires synthetic graphite, or graphite, sorry. And you can make synthetic graphite from coal. It's an important application and actually competes with making carbon fiber in cost terms. We talked about gasification. I show a gasifier here, the Texaco gasifier. This industry continues to grow rapidly, and actually more countries are going to build coal gasification because they don't have their own gas. And with current LNG prices, their products will be uncompetitive. And so they're moving towards coal gasification. You can make hydrogen, you can make ammonia, our potential new fuel to reduce the impact of coal power plants on the environment, existing coal power plants. You can substitute ammonia. So this industry is growing, but it desperately needs carbon capture. And if there's not storage, it needs the technology to recycle the CO2 into other products. And I know the aviation industry is very interested in these recycling CO2 projects. The bottom of the picture is agriculture. And the problem is that our global soil condition is in decline. We have very few options on how to reintroduce carbon into the soil. The methods we used at the beginning of the 20th century supported about 2 billion people. We have to use nutrients to support 8 billion, but the pollution associated with that is a disgrace to the chemical profession. So my last two slides, I've talked about how we can use coal to reduce the impact of many of the items identified by the International Panel on Climate Change. We can use coal to make a massive difference to the energy demand and cost of introducing this new hydrogen infrastructure. The market on rare earth elements could hold many countries to ransom and make this unaffordable. Can we use rare earth elements from coal? Well, yes, we can. It's just down to commercial development. We've talked about carbon fiber in buildings and construction and the shortage. Oh, it's just flicked on to the next one. I'm too slow. Construction. How do we reduce the energy demand and resource demand as we have more people to accommodate? So this development of coal as a resource is very timely, and it does need a reset from the international community in how you regard coal, not just as a fuel that's making carbon dioxide and greenhouse gas, but actually use it in a more clever way, so it can actually help us achieve this goal of the energy transition. And finally, I have to emphasize about the rare earth elements. The hydrogen valleys in Europe will be used to electrify and decarbonize our industry. But the demand for rare earth elements is set to rise by a factor of 20. Even, China holds a monopoly by an accident of geography over critical elements, and there's nothing wrong with that. But how can they meet this demand? We have pilot plants demonstrating commercial recovery from coal. The processes have been proven in the laboratory, and we can introduce these with higher environmental standards. If you recover rare earth elements from acid mine drainage, that can be part of a a used mine recovery process. And so I think I'll draw that a halt there. I hope you've enjoyed the webinar. And if you have any questions, I'm happy to take them now.
Thank you, Ian. Very interesting stuff. I think I see a couple of questions. Yeah, there's one here. Let me read it out. What advantages are there in choosing to make activated carbon as a processing route that gives coal tar for pitch for carbon fiber over the typical process obtaining pitch from steel coke production?
Well, part of the issue is that, of course, making steel is quite carbon intensive. And so if we look from an environmental point of view, if we make a product such as activated carbon, which we're going to use to purify waters and other liquids, and may even be part of our carbon capture technology, environmentally that is more acceptable. And also activated carbon is extremely expensive. I just checked the prices for September, and it was running around $5,000 a ton. So if you're trying to find, there's a major challenge in building an industry around carbon materials that meets profitability targets, and so making a more valuable product from the coal is a preferred solution, really.
Yeah.
Okay.
Yeah, that sounds good. I was just wondering, are they doing something in Brazil with fly ash? You mentioned fly ash.
Yeah, yes. You could convert fly ash into zeolites, and originally that was considered for water purification or as an alternative way to make zeolite catalysts, which we use, for all sorts of things. But also, the zeolites can hold on to nutrients such as the nitrates and phosphates we talked about. So it's an alternative to a humates molecule, and it will hold water as well. So you could add that to the soil with your fertilizer in order to lock that materials in, rather than have them washed away and having to put in twice as much, which is a huge, for farming, these fertilizers are their biggest operational cost. Quite hard for making. Well, the article in the Times, when it talked about these things, it talked about toxic farming. That was last week, and so this issue is coming to the fore, and I'm surprised that those companies that are making ammonia are not getting more involved in this aspect of agriculture.
Yeah. It sounds like they should in the future.
Yeah.
Yeah. There's just one more question ticked in here. Let me see. The general approach in Europe is against coal, as CO2 and coal are put on equal basis. There are disruptive ideas to use CO2 on a profitable way, but there is no finance even for the first steps. That's, I guess.
Well, on the CO2 recycling, actually, there's quite a lot of funding within Europe and also in Japan to use hydrogen that's been generated from renewable electricity to convert CO2 back into a syngas and then probably methanol, which could be used directly, or into synfuels for aviation. I mean, when you look at aviation's options, and that's about the same size as concrete for emissions. They can do offsetting, so they could support forestry, but that's been quite difficult because of corruption. Or they could make their own fuels, and that's known technology. It's not cheap, but you'd be effectively recycling CO2 and using renewable electricity to generate it, the hydrogen for it. So it's a route for them to meet their zero carbon requirements. Yeah, coal has been completely demonized, I think attitudes have changed slightly as it's actually an emergency fuel supporting Europe at the moment. And one of the questions we had at our workshop was from South Africa: can we be more pragmatic about using coal, because we have power cuts at the moment, and so if we shut down our coal stations, we'd have no electricity at all. So can we be a bit more pragmatic? Well, yes, perhaps the transition has to happen, but at different speeds as we find solutions that make sense. I mean, the Baltic Hydrogen Valley project makes sense because there's a lot of water available for making the hydrogen. But the materials resources shouldn't be underestimated in these projects. When they say, oh, zero carbon, you really need to look at the whole life of the project and see, and actually the demand for resources is enormous. Every turbine needs a ton of rare earth elements. And we're not building one hydrogen valley.
Fascinating. This the same question here, or following on for that, it says where to turn to support CO2 transformations.
Well, actually, I was trying to remember. We had someone from the EU at our workshop who is promoting that technology. But there are definitely EU funds available for that. I don't know if you could follow that up, Benedicta, for him.
Yeah, I'll see. We have the slides for that. And there's one more just ticked in here. F1 Formula One cars have been using carbon fiber chassis since 1981. Why is it taking so long to see carbon fiber in everyday cars?
It's simply down to cost. It makes absolute technical sense. The heavier your vehicle, the more fuel it will require, the harder wearing on the tires, and so on and so on and so on. It's a superior, carbon fiber is vastly superior material. And when we look at this resource issue and electric motors, demand for rare earth elements is an example, but lithium for batteries and so on, we need to reduce that, and making lighter vehicles needs less power to move them. It's as simple as that. But the cost of carbon fiber has to come down, and for that we need an alternative source to coking plants, because they're linked to blast steel production, and that's basically in China.
Yeah, good. I think we're coming on to the end of our webinar, Ian. That's all we have time for today. Thank you so much.
Yeah, thanks for the questions. I hope people find that interesting and perhaps start to reconsider how we can use coal.
Exactly.
Yeah.
And all that's left for me to say now is that the slides from this webinar will be available to download from our webinar page shortly. And the next webinar from us will be on the 14th of December and presented by Dr. Chen Su. Thank you all for joining us today, and goodbye.
Hi, Benedicta. Are we finished?